Okay, so let's go through a few examples with these. Okay, so we'll do a few different examples, and I'll give you some homework questions to do after this. But this should be, if you're doing this in pre-calc, this should be review for y'all. It shouldn't be too hard. But we'll start with this one. Find the vector sum of 15 kilometers and 25 kilometers when the angle between them is 135 degrees. So let's draw what we're looking at here. So we have 15 kilometers, and the angle is 135 degrees. So it's going to look like this. That's roughly 135 degrees. So we have 15 kilometers. This is 15 right here. 25. This probably should be a little longer than that. Maybe about right there. So what we want to do is find the vector sum. That means the hypotenuse. So we're going to connect the lines from where we started. So what we did is this. We started right here. We went 15 kilometers down, made 135 degree angle, and went 25 kilometers that way. Where do we end up? How far do we displace? We started from here, point A, we went to point B. What we want to do is find out our displacement, the dashed line, from where we started to where we ended. How do we do that? Well, if it's not a 90-degree angle, which it's not, we have to use a law of cosines to do this, which you learned about in pre-calc and in this class. So we can use a law of cosines if it's not 90 degrees. Okay, so this is angle C right here. 135 degrees would be angle C because it's the angle opposite our unknown. So our unknown is C. So that's going to be our first one. C squared equals A squared plus B squared minus 2AB times cosine of angle C. So again, how do we know which one is C, A, and B? Well, C is our unknown. And so that's always the first one right here. So our unknown goes first. It's the angle of the unknown as well. The other sides are A and B. It doesn't matter which one is A or B. It can go either way. But we'll just call this one A and this one B. But we get the same answer if we reversed it. Because we can do 2 plus 3 and 3 plus 2, it's going to be 5 either way. And we can do 2 times 3 to get 6 or 3 times 2 to get 6. So either way, when you multiply and add A and B, you get the same result. So it doesn't matter which is A or B. What matters is which one is C. And that's the one that's not known. So C squared equals A squared plus B squared minus 2AB. To erase this. Times cosine of 135. So all we need to do is multiply this out, get the square root, and we get the answer. Does anybody have that? Yeah, Lauren? Not quite. Is that what you got too, Will? Well, that's, oh, you know what? I'm sorry, look at the wrong one. You're both correct. I'm sorry. I was looking at a different one. Sorry about that. No, you're good. So yes, 37. Now with significant figures, we just have 2 here, right? 15 is just 2. So we have to just have 2 for our answer. So yeah. Good. So that's 3, right? But we have to go with the lower amount. So when we're multiplying 2 and 3, we go with the lower amount. And so we'd have to go with 2 for the answer. So we'd have to have 37 will be our answer. So side C is 37 kilometers in this situation. So again, this should be review. We've already gone through this in 2 classes now, so should be pretty cemented in your mind at this point. Let's go back to this problem though and do the same 2 sides. So we still have 15 and 25 kilometer angles, but it's at an angle of 90 degrees. So in this case, we go down 15 kilometers, angle of 90 degrees. We then go this way, 25 kilometers. Again, we're trying to find out our displacement, the hypotenuse. We start right here, we end right there. So 90-degree angle, we can use Pythagorean theorem. We would just do 15 squared plus 25 squared equals c squared. 15 squared plus 25 squared, square root that, and we get the hypotenuse. So when we have a 90-degree angle right here, we can use Pythagorean theorem to solve for the side. Does anybody have that one? Very good. And then with sig figs, there's just 2 here. So you have to have 2 for our answer. So what is it? Okay, good. So we got 29 for our answer for that one. So that's pretty basic stuff. We know how to do that. Let's go on to things. I don't know if you've seen this yet or not, but it's not hard. Did you learn about cosine and sine being tied to the y and the x-axis? Okay, good. So you're familiar with that idea. So you know that if you're looking at an xy coordinate plane, this is the, sorry, reverse the axes there. So you have the x-axis, you have the y-axis. And if you were to have this vector right here, vector A, vector A has 2 components to it. It has an upward vertical component and a horizontal component. So we would have a value for x and a value for y. So A of x would be how far horizontal it goes. And then A of y would be how far up it goes. So that's the vertical and horizontal component of the purple vector. And there's also an angle associated with the vector. We have theta of this angle right here. So did you learn that you can multiply the vector A times cosine of the angle to get the x component? You taught that in pre-calc? Okay, well, let's go back for a second before we do that then. Let's think about this. So let's say we wanted to know what is the x component here? How far horizontal does this vector go? How can we solve this? Well, let's think about what cosine is and what sine is. Cosine of theta equals what? In terms of the triangle sides. Yeah, Lauren? Right, so adjacent over hypotenuse. So in terms of these sides, what would that be? It'd be A of x over A, right? So cosine of theta would equal A of x over A. Sine of theta, what does that equal? Robert? Good. So A of y over A. Now, cosine and sine are ratios, which means that we can make one side whatever we want it to be, and the other sides would then fall into place. Like, we can make this hypotenuse equal to 1. Let's just say the vector equals 1. If that is the case, then these sides would have a certain ratio to them that would not change if you had a side of 2 for the hypotenuse or 3. So if we just make this a convenient value, which would be 1 in this case, what happens here? We get cosine of x, or cosine of theta, equals a of x, and we get sine of theta equals a of y. And so that's why that's true. We can, now what we can also do is this. Let's say that they're not 1. Let's just do that. Actually, it'd probably be easier to say it this way, make it more general, because that's not useful in every case. Let's go back to this. Let's say it's not 1. What can you do? You can multiply both sides by a, right? And you can solve for a of x and a. So this one right here, we can move a to this side, and it can become a of sine of theta equals a of y. Same thing here. We can move a over to that side, and it can become a of cosine equals a of x. That's more useful to think of it that way. Where we take the vector magnitude, which is a, and multiply it by cosine and sine. And that would give you the vector a for its x and for y component. So again, if it's 1 for the hypotenuse, it's easy. But if it's a different number, you would take that number, the hypotenuse, and multiply it by the cosine and the sine of theta to get the x and the y components. So let's say that the vector equals 5. And the angle is 45 degrees. We want to know how far horizontal does it go and how far vertical does it go. So we would take the vector angle, or in the side length, 5 is the length of the vector, multiply it by cosine of the angle, which is given to you in this case 45 degrees. 5 times cosine of 45 would give you the length of the horizontal component right here. And then for the y component, same thing. You do the vector length times sine of 45 degrees. And that would give you each of these two lengths. Be sure that you're in degrees, always in degrees for these problems. You won't get the right answer. Does anybody have these? So if you do 5 times sine of 45 and sine of cosine of 45, what do you get for those? Hello? 3.5? Okay. Yeah, it should be the same. Yeah, so 45-degree angle, you will get the same answer for both. So they will be both the same in this case. They're not always going to be, but if it's 45 degrees, they will be the same exact sides. So each one of these is 3.5 in this case. And then tangent, which we won't, I don't know if we're going to use that one as much or not, but just so you know, tangent is opposite over adjacent, right? So tangent of theta would equal a of y over a of x. So just for information, probably would be good to have that one too on your note card. I don't remember which ones we use the most in this class, but it's good to just know them all in case you need them. Any equations you can have. Just don't write down words on your note card, but equations are fine. A is the hypotenuse or the vector length. It's the purple line on here, but it's just the length of the vector. Like if you're walking, say 5 kilometers, and you walk at this angle right here, how far north did you go? Well, you went 3.5 kilometers north, and you went 3.5 kilometers to the east. A of y would be 3.5 here. It's your y component. A of y is 3.5, yeah. But A is 5. But I'm not sure what you're asking. Is that?
Yeah, I was asking if so if when you put it in,
In-
just be 3.5 y was
Oh yeah, just 3.5. Yeah. Okay, anything else about these before we go on? Does that make sense to everybody? Okay, other thing to think about is the coordinate plane where you have 4 quadrants, right? So you have x and the y-axis. You have quadrant 1, 2, 3, and 4. In quadrant 1, let's think about what y and x are as far as positive and negative. So y is positive and x is positive in quadrant 1, right? What about in quadrant 2? So yeah, y is positive, x is negative. And then quadrant 3, what do we have? Negative y, negative x, right? And then quadrant 4, we have negative y, positive x. We can tie these to sine and cosine. And so we can tie the y, x values into sine and cosine. And so if y and x are positive in quadrant 1, then the sine value and the cosine value are also positive in quadrant 1. So we would say it's also positive sine and positive cosine in quadrant 1. Quadrant 2, we have positive sine, negative cosine. Quadrant 3, they're both negative. Quadrant 4, sine is negative, cosine is positive. And then tangent, we could also think about as being y over x, right? So tangent here, it's positive divided by positive, right? So tangent is just positive here. What about tangent in this one? Positive over negative, right? So that gives you negative. So tangent is negative in quadrant 2. What about in this one? We have negative divided by negative, which gives you positive, right? So tangent is positive in quadrant 3. This one we have negative or positive, so that gives you negative. So it's helpful to remember which ones are positive, negative, which quadrant, both y, x, and then sine, cosine, and tangent values. It'll become more helpful as we go on in this chapter. But for now, just be sure that you can draw this and understand why they're positive and negative in each quadrant. Okay, does everybody have those down before we go on? Okay, we'll go through one more example and I'll give you some questions to work on before class ends. For this one right here, there's a house you're trying to walk to that's 15 kilometers away. And it's 40 degrees west of north. So let's draw what that means. Okay, so if you were to draw an XY coordinate plane, north, south, which way is this? East. Have you ever heard about never eat soggy waffles? So that's one way to remember it, but east is rightward, west is leftward. Okay, so 15 kilometers away west of north, what does that mean? Well, so this way is north, right? West of north, well, we have to go this way, right? We would go 40 degrees west of north. So the house would be about right here. That's 40 degrees west of north, and it's 15 kilometers away. So we would have our vector be 15 kilometers, like that. But the only path through to get to the house is through woods 5 kilometers north. So you have to start right here and go 5 kilometers north. And then there's a clearing, you can then head towards the house. So you start going up that way, and then you go this way. And what we want to do is find out, actually make this a little bit easier. Well, we could do that too. But let's switch this up a little bit. Let's say that we know that this is 15 kilometers right here. And we don't know this one. That actually makes it easier to work through. So let's say we have that. What we know is that we went up 5 kilometers north, 15 kilometers this way. What we're trying to do is find out the house. So we know this. We know we went 5 kilometers upward, and then we went to the west, like that. And let's just say for this one that we went 40 degrees to the west, and we went 15 kilometers. What we want to do is find out our displacement from where we started to where we ended. So we want to find the blue line, both the hypotenuse, the length of it, and the direction we went. So basically what we have is we have two vectors. We have the red and the purple vector, add them together. We want to find out the blue line. How do we do this? Well, there's a few ways you can do this, but oh, this one right here? Okay, good. So so we know that from the red to all the way over here at 180 degrees, right? And we do 180 minus 40, and that gives us 140, right? So so we can say, well, it's 140 degrees right here. That's good. Okay. And then what do we do from there? Good. So we can use law of cosines, right? Because what do we know? We know an angle. We want to find this side, but we know two other sides. If we know two other sides, and we know the angle of the unknown side, then law of cosines will give us the answer. Yeah. Law of sines can give you some problems. I wouldn't use it in this class. Law of sines can be tricky, and it's not. There are certain times when it's hard to know when to use it. I would just not use it all in this class because it doesn't always give you the right answer. I don't really want to get into when it does and when it doesn't give you the right answer, but just know it doesn't always give you the right answer. You have to know when to use and how to use it. So I just would only use the law of cosines and not the law of sines in this class. Law of sines, yeah, I just won't even get to it right now. But we'll just always use law of cosines for physics. Law of sines, I'll let you do that in pre-calc. Okay, so we say that this is side C, and C squared equals, doesn't matter which one's B or A, we'll just call this one A and this one B. So we have 5 squared plus 15 squared minus 2 times 5 times 15 times cosine of C. Oh yeah, we know C is 140 degrees. So basically we just multiply, subtract, add it all together, and that will give us the side of the hypotenuse, the side we don't know. Hmm? Right.
So would that translate down to the included angle from C and A? Would that also be 40 degrees?
Oh, right here. Well, let's see. I didn't draw this very well. So if we have it as a straight line, straight down like that, and we have the transversal that cuts through here. So we know that one is 140. We don't know that side or that side. We know that this one, so we know this is 40. We know that would be 40. We know that much. But as far as that one goes, I don't think we can know what that one is at all. Sure. Because I don't know what we can say about the blue dash line. Yeah, and I decided to change it because I didn't want to do what we had in the diagram because it's not worth doing.
And then from here to here it was 40 degrees.
Right.
So I was wondering if this angle, you can go to this angle. Which, I mean, this picture doesn't do a very good job of it, but I guess it wouldn't work.
No. Yeah, you can't figure out the other two angles without more information. Okay, can we find out the side for the, yeah, I got it one, 19? Okay, so that's how we use law of cosines to determine vector displacement. Okay, got about 5 minutes to go. Let me see in the book what you can work on today for homework. And I have your test to pass back too. On page 121, work on 1 through 4 for homework tonight. On page 121, 1 through 4.